In this video, we're going to solve the equation negative 3x plus 20 equal to 5 by graphing. The way we do that is we make each side its own equation. We're going to make the first side y equals negative 3x plus 20. We'll make the second side y equals 5. So starting with the red one, the negative 3x plus 20, the y-intercept is b, or 20, and our slope is negative 3, or negative 3 over 1. So if I plot 20 on the y-intercept, we have it there. And then for our slope, down 3 over 1, so down 2, 3 over 1, down 1, 2, 3 over 1, just continuing that pattern. I'm going to put a few more dots than normal on for this. Okay, I think it should be good if I can draw this in straight. So when you're doing this by hand, having good straight lines is essential. So there is the first graph, the one in red. Now we have y equals 5, which is just a horizontal line where y is 5. So here's where y is 5. So horizontal line going through. There we go. Now, to actually solve the equation by graphing, we simply look at where the lines intersect. That point is the solution. Since it intersects at the x value of 5, and the original equation only has a single variable, the solution is x equals 5. It's just the x value where the two lines meet. Oh, man. Okay, we're going to solve the equation. The absolute value of x minus 4 is equal to 1/2 x plus 1. So going through, to do this, we make each side its own equation. So y equals absolute value of x minus 4. And y equals 1/2 x plus 1. I'm going to start with the one in blue, the linear piece. Our y-intercept is going to be 1, and our slope is 1/2. So plotting 1, then our slope is 1/2, so we go up 1 over 2, up 1 over 2, up 1 over 2. Just putting a bunch of them on so I can try to draw this as straight as possible. There we go. Now for the piece in red. So that is an absolute value function. So going through, we can use the transformations to graph it. Inside x opposite, outside y same. So in the red, we have the rule x plus 4, since it says x minus 4. So that is our rule. And then we can do this to our points that we use for transformations. So normally negative 1, 1, 0, 0, and 1, 1. We're just adding 4 to each of our x values. So negative 1 plus 4 is 3, 4, and 5. My y values are not changing, so 1, 0, and 1. Plotting those 3 points. Negative 3, 1, 4, 0, and 5, 1. It's going to be a V shape. Going through, trying to get the slant of the line as best as I can. And then on the other one, going in the other direction, there we go. You can see this time we have two intersections, right here and right here, which means we have two solutions. Those two solutions are at x equals 2 and x equals 10. And when you're solving by graphing, it is always nice to check using a graphing calculator. So I didn't do that on the first one, but I'm going to do that one here since this one's a little bit more spread out. So absolute value, there it was. Absolute value of x minus 4 is the first piece. And the second piece was 1/2 x plus 1. We just double check. We can see that 2, 2 is one of the points, so x equals 2, and x equals 10, just as we found. So in this example, we're going to solve this system of equations by graphing below. Solutions for systems are slightly different. Solutions for systems, because there are more than one equation solved at the same time, usually require more than one value. So in this case, because our equations have two variables, we are going to have an ordered pair for the solution. So let's go ahead and start. I'm going to do the first one in red. The y-intercept, or b, is -3, and my slope is 2. So plotting that, -3 is my y-intercept, my slope is 2, as a fraction that's 2 over 1, so we're going to go up 2 over 1, up 2 over 1, and so on. Hopefully that's as straight as possible. Now for the blue one, or the second one, which I'm going to do in blue, my y-intercept this time is -1, and my slope, since there is no number beside x, is implied to be 1. So y-intercept is -1, my slope being 1, so I go up 1 over 1, up 1 over 1, up 1 over 1. I can see where they intersect, so I really don't have to worry about going straighter now. So we're going to draw that in as best as possible. That was not the best straight line. But two lines can only intersect in one spot, or infinitely many if they are overlapping. Since these two clearly already have their intersection, we can easily find the point. So that is the spot, or the solution. The solution, therefore, is 2, 1. A system solution is an ordered pair, not just the x value. In this example, we're asked what is the solution for the system of equations below. So if you look, solutions when represented graphically are intersections between the two lines. You can see the blue line and the green line, they have no intersections. In fact, they are what is referred to as parallel, running beside each other but never actually intersecting. Since they have no intersections, and intersections is solutions, that implies that there is no solution. It is what is referred to as an inconsistent system.